Alright, y'all. Today we're going to do an introduction to forces. So if you've ever seen Star Wars when they're like, Luke, use the Force, it's kind of like that, but not really. So this is what we're move. We've been tracking the motion of objects for a while, but now we've got to figure out why they move. And our objective is we will describe the four main forces, and our homework is to finish our packet. Note number 1. Gravity pulls objects down toward the center of the Earth. It acts on all objects all of the time. This is why things stay put on the ground. If an apple falls, I know that gravity is pulling it down. Note number 2. Normal force is the force that pushes up from the ground to make sure we do not fall into the center of the Earth. So if gravity is pulling this box down, the only thing that's preventing it from falling through the desk is the normal force that's pushing up on it. Note number 3. Objects move when a force is applied to them. This is called the applied force. So if my man is pushing the ball and he's applying the force to the right, I know my applied force is moving to the right. Note 4. Objects slow down and stop because of friction. This force opposes motion. So if I'm putting an applied force going this way, I know that the mass is eventually going to stop because friction is pushing it the other way. And note number 5. A force diagram represents the forces acting on an object. We have to draw the diagram below. So I want you to draw the box, and I want you to draw that gravity is pulling down. My normal force is pushing up. If I'm putting an applied force to the right, my applied force arrow goes to the right. And I know that friction opposes my applied force, so it always goes in the opposite direction. Practice question number 1. What is the force that is applied to an object that makes it move? Practice question 2. What force pushed against the direction of your motion on the ball and made it stop? Practice question 3. If the ball was sitting on the table, draw the forces acting on the ball. Right now, as the ball is not moving. And question number 4. Which forces acted on Earth all of the time? What would happen if it did not exist? And our last practice question. What was the force that moved the ball? Draw the ball and the direction of the force arrow